Today, we're going to talk about proofs. We're going to start kind of basic and we're going to work our way progressively. All these proofs have to do with congruent triangles. And what I recommend is you write down everything I write down, and then you'll have these proofs to reference in the future. Okay, proofs are basically mathematical statements with a justification or a reason for every single step. So in algebra, when you do a math step, you just do the math, and each time you just make a step. Think of that the same way, but for every step you make in the problem, you have to give a rule, a reason, or a theorem. So if you don't remember the actual title or the name of the theorem, it's okay. You just have to explain that theorem step by step. So knowing the rules and the names actually saves you a lot of time. But if you don't remember them, at least explain them. Okay, here's our first proof. It says given JK is congruent to LK. That should have a segment above it. JM is congruent to LM. And we're going to prove that these two triangles are congruent. So this is what you do in every proof. Step one, write the given. So I'm going to write exactly what I see here. I copy it step by step, symbol by symbol, everything. And so you are literally copying. It's the one time I think copying is fabulous. The only time. Okay, JK is congruent to LK, and JM is congruent to LM. I copied it exactly the way it was written, and for my reason, I literally write given. Okay, this will give you some points. So what I tell my students is that if you can write at least this, you're not getting a 0. Okay, in my class, you might get different points than another class, but you will not get a 0 if you at least start here. Start with what's given. Now, every proof ends with what you're trying to prove. So keep that in mind that this right here, triangle KJM, is congruent to triangle KLM. Keep that in mind that that will be down here at the end of our proof somewhere. We just have to get there. All right. So once I have my given, I look at my given and say, okay, well, so what? So you have to visually see it. Most students who see it can do it. So what I'm explaining is seeing it, like literally seeing it on the picture. So JK is congruent to LK. Oh, there's my tick marks. I literally see that they're congruent. And then JM is congruent to LM. I can literally see they are congruent. Now, I look at my given. Is there anything else from my given that kind of like leads me to something else? Well, not really. It just says they're congruent. So then I look at my visual and say, is there anything here I'm supposed to know? And when I mean supposed to know, that can mean like I'm supposed to know vertical angles are congruent. I'm supposed to know shared sides or shared angles use the reflexive property. You might even, if you were given something about parallel lines, you might need to know alternate interior, alternate exterior, corresponding angles, or same side interior angles. So you have to think about all those things that, what are you given? Does this lead you to anything else? And if it doesn't, let's see if your visual leads you to something else that you're just supposed to know. So I look at this and I'm like, okay, you might not see it, especially if you're new at proofs, but I'm going to hopefully be able to share this with you. I'm going to color code it. This right here is an orange triangle. Kind of looks pinkish. Oh, kind of looks orange, I guess. Okay, this orange triangle right there is KLM. That's this triangle, KLM. Okay, and I'm going to trace the other triangle, KJM. I'm trying to get a little bit outside the lines just so you can see the color. There's my green line. It's hard to tell that it's green, but it doesn't really matter. Okay, just that it's a different color than this orange over here. Look at those sides. There is something they have in common. That middle segment or side length, KM, is the same on both triangles. So if it's exactly the same, then of course it's congruent, but you have to write the rule. So I'm going to put a set of 3 tick marks here, and I'm going to state, even though this may seem obvious to you, part of the proof is writing every single step. Whether it's obvious or not, you have to write it. So I'm going to say KM is congruent to KM. And there is a reason. I could say they share the same side. That would be fine. but there's a name for it, and it's called reflexive property. Okay. That's a little bit shorter than they share the same side. Okay. Now, what I do with my visuals is I make sure I have everything I need to make a rule for triangle congruence because I'm trying to prove triangles are congruent. So I've got a set of sides. Here, let me use a different color. Hopefully it will stand out a little bit. Here's one set of sides. Here's another set of sides. And here's right here in the middle, that's another set of sides. That's two sides, but they share the same one. Okay, so my rule is side, side, side. I have everything I need. In fact, I could label it here. Here's a side. There's a side that I have. And here's a side that I have. I have side, side, side. So I'm verifying not only in the picture, I'm verifying in the list of statements. Be careful though. The list of statements might be out of order. Trust the picture. In this case, you can't really tell. It's just side, side, side. But what if it was like side, angle, side? If the order in the statements is wrong, that's fine. The order of the picture has to be right. So I look at this. I've got side, side, side. That is one of the rules to prove triangles are congruent. Therefore, I can prove this. So I'm going to take my last step. Triangle KJM is congruent to triangle KLM. I look at my pictures, it's all labeled. I look here, it's all labeled. It's literally giving me the answers by side, side, side. All right, here's our next proof. I'm given that BA is congruent to ED. C is the midpoint of BE and AD. So there's a new vocab that we haven't used in a while, midpoint. And I need to prove that these triangles are congruent. So start just like you start every proof, write the given. So here's my statement. And I'm going to copy exactly this information. And it might be a good idea, especially as you're new at proofs, to actually highlight or circle or color code or something so that you know that you have the entire given, not just parts of it. So BA is congruent to ED, and C is the midpoint, and I am just abbreviating it, midpoint of BE and AD. And that's fine. Okay, what's my reason? Given. Now, just so you know, the given could be broken up. Like I could say this first given here, and then later on in the proof, the second part of the given, I'm just putting it all together. So I've got these 2 points of the given. Okay, now, I look at this. I need to label the visual. I need to actually see it. So BA is congruent to ED. Those are congruent. And then this given actually is telling you something you're supposed to know. So it says C is the midpoint. Well, what does midpoint mean? It means the point in the middle. So if you understand an actual vocabulary that's given, or like a symbol, like let's say they give you the parallel sign or perpendicular symbol, so you would have to know what that means, and that actually gives you your next step of your proof. So I know what midpoint means. It means the point exactly in the middle, which means 2 things will be perfectly the same length. So if I have a segment and there's a midpoint, each of these sides or segments are congruent. So I'm going to look at this and I'm like, C is the midpoint of BE. So I look at BE, I'm like, okay, this is the same as that. BE, C's in the middle. But it also says it's also the midpoint of AD. So I look at AD, and I'm like, oh, this is still the midpoint. So I'm going to say, hey, this is the same as this. So I look at the given, see if there's any vocab, symbols, or anything that leads to something I'm supposed to know, and I mark that. But I can't just mark it and move on. I have to give the reason and like what's happening. So I know, step 2, that BC is congruent to EC because of the word midpoint. I also know that AC is congruent to DC because of that word midpoint. So since it's because of this word, I literally take that word and I'm putting an arrow. So you remember, if it's a given a word here, you're going to write definition of that word. Okay, so I look, I see what I've had so far in the visual, and I've got this set of sides right there across from each other. I've got this set of sides that has 3 tick marks, and I've got this set of side that has 2 tick marks. Oh, I've already got side, side, side. I can already say that these triangles are congruent. And I look here at my statements. I've got a side that's congruent to another side. Here I've got a side congruent to another side. And here I've got a side congruent to another side. I can prove that these triangles are congruent already. So I'm going to write step 3. Triangle ABC is congruent to triangle DEC. What's the reasoning? S, 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 S. Side, side, side. All right, I'm going to do another proof. This proof is a little bit different than the last 2, but still the same concepts apply. So start with that given. I'm going to take my given and write it down. Step 1. BC is congruent to DC. That's given. And AC is congruent to EC. Remember, I'm copying this whole chunk of information exactly the way it's written, and I'm saying my first reason is given. Whoops, that should be a 1. Once I have the given written down in my proof, then I go and visually see it, like actually mark it on my visuals. So BC is congruent to DC. Those are congruent. AC is congruent to EC. Those are congruent. Okay, so I've got my visual. And then I look up here, is there anything in the given that leads me to something else that I'm supposed to know? I look here and I'm like, well, they're just congruent. That doesn't really help me because it doesn't tell me, there's no vocabulary in there. It doesn't say like midpoint. It doesn't have the word parallel to like lead me to something else. So then I'm like, okay, I'm done with the given. I need to now go look at the visual. So I look at the visual. Is there anything here that I'm supposed to know? And I'm like, well, not sure yet, but I do have these 2 sides. They're congruent. And I have these 2 sides. They're congruent. So I'm like, oh, I still don't know. So I go over here and I'm like, okay, I'm going to mark this. There's a side. There's a side. So I definitely have 2 sides. I either need another side or an angle. So look at this picture. I'm hoping you see something that you're supposed to know in this visual. It has to do with angles. All right, so let's look at it. There are vertical angles in this picture. And on this visual, vertical angles, and in every visual, vertical angles are always congruent. So if you find these vertical angles across the vertex from each other, then you should know, just supposed to know, that those are congruent. So I'm going to write step 2. Angle, and make sure to get the order right. I'm going to go from BCA and then do that same order, DCA. So angle BCA is congruent to angle DCA of A. Oh, no, that's right, DCE. I saw it right. So BCA is congruent to DCE. Angle BCA is congruent to DCE because of vertical angles. And again, you're not going to be told that. You're just supposed to know it. Okay, so I'm going to write, hey, there's a set of angles. Angles. They're just both right there. Now, if I look at this order, ASS or SSA, that's not a rule you're allowed to use. Remember, the order in the visual does not, or the order in the proof does not matter at all. It's the order of the visual. So I look at this visual and I'm like, side, angle, side, side, angle, side. That's the order that matters. So I'm going to write in my last step why the angles or why the triangles are congruent. Step 3, triangle BCA is congruent to triangle DCE because of side, angle, side. Okay, I really like this proof. This proof is a great proof because it has a lot of given information that leads you to more information. So if you don't understand the given information, then that gives you like red flags. You need to go back and study a lot of the symbols and the vocabulary. Okay, so let's look at the statements. I start every proof by writing down all the given, every single part of it. So again, I recommend highlighting it or boxing it or circling it so you don't forget any part of it. So step 1, C is the midpoint, and again, I just wrote midpoint abbreviated of BC or BD. Also, I'm going to put little bullets so I can keep track of them. AB is perpendicular to BD, and BD is perpendicular to DE. Now, if you didn't know that symbol, that would be something that you need to go back and practice and review and make sure you understand, first of all, what the symbol means, perpendicular, and what does perpendicular mean. So this is given. Okay, once I have the given, I look at what is given and mark up my visual. So C is the midpoint of BD. I need to look at BD, and if C is the midpoint, that means it cuts each of these parts perfectly into congruent segments. So how do I know they're congruent? Because of that word midpoint. Midpoint means it's cut perfectly in half. Okay, so I say, okay, that's one thing I know. And then I look down here, and again, if you don't know what the symbol means, go look it up. But this means perpendicular, and that means they intersect at a 90-degree angle. So AB intersects BD at a 90-degree angle. So I'm going to put a little 90-degree box right there. And BD intersects DE at a 90-degree angle. And I knew that because of that symbol right there, the definition of perpendicular. Okay, that's all I've got so far. Now I got to explain what I just marked, because it doesn't tell me that these are congruent, and it doesn't tell me that those are 90. I knew that because of the given. So what I do is I'll start with a midpoint. I'm going to say BC is congruent to DC. And again, I usually underline that word and move it on so I know use that word. Definition of midpoint. So I use what was in the given to help me make the next step, which just explained the markings I put on the picture. Now, step 3, I need to explain this symbol and why I put a 90. Okay, so that's another kind of like a definition. So I'm going to say step 3, angle, these angles right here, ABC equals 90 degrees. And I'm going to say the measurement, that little M right there, measurement of angle ABC equals 90. And I'm going to say the measurement of angle EDC also equals 90. How do I know that? Because of this word or symbol. That word right there, or that symbol, is the definition of, and you can write perpendicular. I could say definition of and just put the symbol, because that's what it is. Definition of that symbol, perpendicular. So I use what's in the given to lead me to the next 2 steps. Now I have to go look at this picture. I don't have any more given information that's going to help me. So I have to go look at the visual and see if there's anything I'm supposed to know. And I'm hoping you see it. I have angles. I have sides. Now, if the hypotenuse was marked, I could say this is HL, but I don't know anything about the hypotenuse at all. So I have a feeling it's not going to be HL. But I'm going to still go and I'm going to say, okay, I have a side here. And I have these 90s, but I didn't actually say that they're congruent. So I need to do that. Step 4. If one angle is equal to 90 and the other angle is equal to 90, wouldn't they be equal to each other or congruent to each other? So I'm going to say angle ABC is congruent to angle EDC. And I could say they're both congruent to the same amount, or their measurements are equal. That is called the transitive property. Okay, and because I'm switching from measurements to congruence, some teachers require you to say that if the measurements are equal, the angles are congruent. So I'm going to add that. Not all teachers require it. So I'm going to say measurements are equal, so angles are congruent. I'll slide it over so you can see it. The measurements are equal, so the angles are congruent. That might be required step. I just don't know. It depends on your teacher. Okay. So if you're switching from measurements to congruencies, you might need to talk to your teacher about that. Okay. Now, I've got this angle. I know that the two angles are the same. So I have a side angle. And in my visual, I have a side and an angle. I'm just hoping you see the extra information that isn't written, and I'm going to highlight it right now. I should know that these two angles are congruent. And that would give me another set of angles. So I would have angle, side, angle. Angle, side, angle. But I first have to say, well, how do I know those are congruent? And so that would be step 5. So step 5, angle ACB is congruent to angle ECD. Do you remember what those angles are called? They're across the vertex from each other. Vertical angles. So if you have vertical angles, they will always be congruent, which means I now have another angle. And remember, the order in the actual proof doesn't matter, because this order you would think the rule is AAS or SAA, but the reality is that the visual is what matters. So angle, side, angle. The very last step in my proof should be the very last thing that you're trying to prove, which it's going to be. So I'm going to say step 6, triangle ABC is congruent to triangle EDC by angle, side, angle. I hope that helps.